Welcome back to Season 2 The Trio. I'm Jialo.
I'm ARFAN.
And I'm Sneha.
Today, we are here to discuss a new topic called the application of differential equation in daily life. This topic is in Chapter 2 of Semester 2 Matriculation Syllabus. If you all have been subscribing us since the last broadcast, you'll find that our topic today is closely related to the previous issue, which is differentiation. So Sneha, can you tell us the definition of the differential equation?
Sure can, Jana. Unlike differentiation, which is the process of finding the derivative or the rate of change of function, a differential equation is an equation that relates an independent or dependent variable with one or more derivatives. However, prior knowledge of differentiation is very crucial for one to be able to solve problems regarding differential equations and apply them to our daily lives. What do you think, ARFAN?
You're absolutely correct, Sneha. This is because in an application, the function generally represent physical quantities. The derivative represent their rates of change, and the differential equation defines a relationship between two. Such relations are common. Therefore, differential equations play a prominent role in many disciplines including engineering, physics, economics, and biology.
Well said, Sneha and Alfred. Differential equations are extremely important in the history of mathematics and science because the laws of nature are generally expressed in terms of differential equations. Differential equations are the means by which scientists describe and understand the world. So, do you all know who discovered differential equation?
I know. Differential equation first came into existence with the invention of calculus by Isaac Newton and Gottfried Wilhelm Leibniz.
Indeed, Arfan. By the way, do y'all know that differential equations can be divided into several types? The commonly used distinction for differential equations include whether the equation is ordinary or partial, linear or non-linear, and homogeneous or heterogeneous. This list is far from exhaustive. There are many other properties and subclasses of differential equations which can be very useful in specific contexts. However, for this case, our focus is on first-order differential equations. Hence, I'd like to inquire about the application of differential equations in daily life. Does anyone know where differential equations can be found in daily life?
Differential equations are widely found in the field of physics. It is found in Newton's law of cooling. For instance, when an object has a temperature greater than the ambient temperature, it cools according to Newton's law of cooling, which states that the rate of cooling is proportional to the difference in the temperatures. The temperature of the object at a particular instance can be determined by a separable differential equation, which is derived from the application of the knowledge of differential equations by balancing the rate of cooling and the difference in temperatures. Besides Newton's law of cooling, differential equations are also applied in electric circuit models. These can be seen in RL and RC series circuit. Let's take the RL series circuit as an example. For a series circuit containing only a resistor and an inductor, Kirchhoff's second law states that the sum of the voltage drop across the inductor and the voltage drop across the resistor is the same as the impressed voltage on the circuit. Thus, we obtain a linear differential equation for the current at the time.
Wow, differential equations sure does help a lot in physics. Besides physics, differential equations are also widely applied in chemistry. First-order differential equation is especially famous in radioactive decay models that fall under the branch of chemistry. Radioactive decay models are very accurate over long periods of time. They are primary methods for determining the age of prehistoric fossils and ancient artifacts. If we denote the decay we are considering by function mt, then the decreasing rate of the decay is dm over dt. To say that the decreasing rate is proportional to the decay is just that saying that there is a constant proportionality of k such that dm over dt equals to negative km. Since k is a constant, this can be immediately separated and integrated to yield m equals to a e power of k negative kt with a equals to e power of c. Besides radioactive decay, Various laws and theories in chemistry such as the Vogel-Lambert-Beer law in spectroscopy, time constants of sensors, chemical reaction kinetics, relaxation in nuclear magnetic resonance, and the RC constant of an electrode also applies the knowledge of differential equations. Anything to add on, ARFAN?
Differential equations are of basic importance in molecular biology mathematics because many biological laws and relations appears mathematically in the form of a differential equation. In this, I will present some application of mathematical model represented by ordinary differential equation in molecular biology. The vast majority of quantity model in cell and molecular biology are formulated in terms of ordinary differential equation for the time of evolution of concentration of molecular species. Assuming the diffusion in the cell is high enough to make the spatial distribution of molecule homogeneous, this equation describes system with many participating molecules of each kind. So in the result, we propose an original mathematical model with small parameter for biological phospholipid pathway. All the equation system include small parameter epsilon. The smallness of epsilon is relative to the size of the solution domain. If we reduce the size of the solution region, the same small epsilon will result in the different condition number. It is clear that the solution for a smaller region is less difficult. We introduce the mathematical technique known as boundary function method for singular permutation system. In this system, the small parameter is asymptotic variable, different from the independent variable. In general, the solution of such equation exhibit matrix-scale phenomena. Singularly perturbed problem form a special class of problems containing a small parameter which may tend to be zero.
I also would like to add on to the numerous applications of differential equations, and this time I wish to go in depth about it in the engineering field. Differential equations are extremely helpful to solve complex mathematical problems in almost every domain of engineering, science, and mathematics. If you are an engineer, you will be integrating and differentiating hundreds of equations throughout your career because these equations have a hidden answer to a really complex problem. Maxwell has given equations for electromagnetic field theory which help us to find the magnetic field or electric field easily by simple integration or differentiation. Various transforms of time domain to frequency domain or vice versa in engineering is only possible because of differential equations. These are just a few examples which I could quote. There are tons and tons of applications of differential equations in engineering, and it is really exciting when you get a hidden answer by solving those complex differential equations really.
Thank you, Sneha. Yep, besides engineering, differential equations are also used in economics. The theory of differential equations has become an essential tool of economic analysis, particularly since computers have been commonly available. It would be difficult to comprehend the contemporary literature of economics if one does not understand the basic concepts such as the Biffer cation and chaos, and result of modern theory of differential equations. A differential equation expresses the rate of change of current state as a function of the current state. A simple illustration of this type of dependence is the change of gross domestic product (GDP) over time. Consider state X of the GDP of the economy. The rate of change of GDP is proportional to the current GDP, where function xt is equals to gxt, where t stands for time, xt stands for the derivative of the function x with respect to t.
In conclusion, differential equations are widely applied in and have profound impact in our daily life. It is present everywhere in our daily life and continually help in human development. Therefore, we must appreciate the comfort and the convenience that the differential have brought upon us by gaining detailed knowledge on differential equations as well as trying to apply in our daily life. Hence, I would like to stop the discussion here for today as this could go on until forever if we continue on. Thank you for everyone for participating in the discussion today.